All right, my name is Tim. I am here from Avinta, and you've just been handed out some good goodies. That's like a cool problem. I want to talk to you today about building data products. Something I've been doing for the last 10 years with my teams, and I've been doing that in a federated business context. So I thought that maybe is a nice way to translate that to some of your businesses as well. So let's start on aligning there. Federated business, what does that mean? So many multinationals today are organized with many local sites that are maybe focusing on a particular region or a particular product line, and a number of central teams that are working in global corporate hubs, collaborating to basically make impact. An example of a global team could be the central data analytics team, trying to figure out how to unify all the metrics in the local businesses and get an overview of the performance. While an example of a local business could be a sales team focusing on the campaigns to manage the region. So the outline for today, I want to go into an example of federated business in a little bit more detail, so we get a better understanding of what this looks like. And then I'll go into some of the data architecture challenges that you run into the business and how we have solved this in Advent. And then I'll go into some use cases for building actual data products. So let's start with an example. So Adventa is a group of online marketplaces. These marketplaces, they are platforms, websites, where a buyer and a seller come together to make a deal. A seller typically has the intention to sell an item that he's no longer using, while a buyer is typically looking for a good deal, or maybe wants to, if he's environmentally aware, wants to be able to give a product a second life. So let's look at Adventa in numbers. So we have many of these marketplaces worldwide, and if you add all the users together, we get 3 billion monthly visits on these sites. If you look at the traffic in a country, typically our marketplaces are in the top 10 of the country's traffic. So you have your Facebook, Google, Instagram, TikTok, and then there's one more marketplaces. So that's how popular typically these sites are. We have 40 such sites worldwide and are operating in 14 different countries. We have 8,000 employees worldwide and 1.5 billion in revenue. So what are these products? Have you maybe heard of them? This is a map of where we are active. The dark blue countries are the countries where we have presence. And let me just pick a few. We're in the Netherlands today, so Marktplaats is the local marketplace here that we own. Germany is a big market for us. We have eBay Kleinanzeigen and Mobile.de. Mobile.de is a car-specific marketplace. And in France, we have Le Bon Coin, also a generalist marketplace that's quite big. So these marketplaces typically have a focus either on general products like phone, laptop, furniture, basically anything goes, or a specialized category like car, real estate, or jobs. So let me give you a very brief history view, because I think this gives a picture of how many of these federated businesses are formed. So the name Adventa might sound new to you, and that's because it was coined only in 2019. But we spun off a Norwegian media group that is 180 years old, with very little debt, so that we were set up for acquisitions. And we acquired last year the eBay Classifieds Group, which brought up Marktplaats and Mobile.de into a few other sites in the portfolio. And that is a typical pattern, both for us and for many of these federated businesses. They grow through growing small sites into big businesses and to acquire sites where that growth fit. And so you see, since the year 2000, we have been active in the online classifieds space and have been acquiring many sites since then. And that also shows one of the first challenges. all these different businesses grew independently of each other and have very different tech stacks and very different ways of being organized. And our way of dealing with that is as follows. So, because they are grown independently, we have separate platforms with local teams, local product and development teams, working on these platforms, building out features on these platforms, rather than a single platform, white label, where we have all the brands. So that already introduces some complexity. And with time, we saw that a lot of these teams are building the same thing, so that doesn't make a lot of sense, right? So we started focusing on building some of these capabilities in our central product and tech teams, and that's what you see here in the dark blue box, the global capabilities. I, as the head of data engineering, have a team in the central organization. I have 6 teams that are building data products that are rolled out to these marketplaces. So we collaborate actively. And then we see other things like a central data platform, product infrastructure, business technology, basically teams that are supporting the overall business to make this work. So let's go into some of the data architectural challenges that we face. I'll talk about data collection, I'll talk about processing, privacy, and experimentation. So because you're dealing with a landscape with very heterogeneous tech stacks, you want to kind of abstract away from it. So one of the first things that we did is build something that we call the data highway. The data highway is basically a collection of Kafka streaming clusters that our marketplaces push data into. And what is key here is that we decided to push that data into a single schema. So all these marketplaces have their own internal warehousing, their own schemas locally, but on the data highway, we use a single schema. This is very powerful because it allows central teams like the one that are in my organization to basically build a product, build an algorithm, a solution once, and then roll it out to all the marketplaces, basically with the flip of a switch, because they all use the same schema. But there's another important aspect, and that is that we don't force the marketplaces to use that single schema. We allow them the freedom and the autonomy to operate their own schemas, but they map their local schema into this central global schema. And that way, they keep the autonomy, and we don't get a very tight coupling between the local marketplaces. And that's very important. Then, as we collect the data, we want to process the data. And for that, typically we use some form of computational clusters. So we started out basically with a setup where every team in the organization, whether it be local, central, can basically start up their own cluster, run it for their purposes, whether it's for development, experimentation, or production. And basically shut it down when they feel, well, as you can imagine, that didn't result to a very high utilization. Utilization means how often is that cluster actually used for processing data. So in that setup, we got around 30% of utilization of those clusters. And these are very expensive setups. They're typically 10 times more expensive as your APIs because they're huge amounts of machines. So that's a lot of waste. So we started looking for different solutions. And mind you, this is a journey that goes over 10 years, right? There are things out there today that weren't available back then. So we built a central data cluster and gave every team a queue on that data cluster. So now, when they want to run a job, they push it into that queue, and it sits there waiting for resources to become available. And as soon as it's at the turn of this team, it processes there. So that lifted the utilization to 70%, but as a result, created dependencies on different teams, so developers were now waiting for their time in their queue, and this would impacts the efficiency of your teams. So it's still not happening. Today, we have a system which is built on Kubeflow. Kubeflow is an open source machine learning platform. It's built on top of Kubernetes, and it allows the teams basically to, when they do a pull request on GitHub, they submit a piece of code, gets reviewed, automatically the cluster gets spun up, runs that code, runs the job, and when it's done, shuts down the cluster automatically. So this is a full continuous integration, continuous continuous delivery set up for these big data jobs and gives us a utilization of nearly 100%. So that's a setup that works really well. Then, as you've collected data, you've processed data, you're ready to serve it to the world, but wait, let's think about privacy. Right? Like, in such a complex setup where you have different distributed teams working across different locations, it's very challenging to have a single team look after privacy. So you need that to be owned by each of the teams that are building parts of that solution themselves. And therefore we introduced something that we call Privacy Broker. Privacy Broker is basically a middleware that sends messages when a privacy request comes in to all the dependent teams that are adding to that equation. Right. So, for example, a user requests on one of our marketplaces, I would like to see a copy of my data. This triggers a message to one of my teams saying, like, you need to make a copy, prepare it for that one particular user, and send it out. So that's a job that runs daily for all the incoming requests. It aggregates the data and sends a signal back to the privacy broker. The data is ready so that the request can be fulfilled. So a very important key part in being privacy compliant in a federated business. And then finally, experimentation. When you build your product,
you want to be able to experiment on real users to see the performance of this product compared to your existing solution, especially in an area like machine learning, data science. You want to constantly be learning of what works better, why does this work better, and so on. And a problem that we ran into is that when you have a model ready and you want to try it on one of the marketplaces, you need one of the local platform teams to make a change in the code to basically point to that new model. And as you can imagine, this means we need to push a piece of work onto the backlog of that local platform team. So that creates delays, right? So now we're waiting for that team to be ready to pick that up. And as a result of that, we typically would run maybe 1-2 experiments per quarter. So instead, what we build is something we call experimentation in the backend. So because machine learning teams are typically operating on the algorithm, they don't have much front-end user-facing features, they make changes that are primarily happening in the backend. So we introduced an API gateway, which is basically an API that can then further route incoming requests and let the marketplace integrate with that gateway. So the gateway is owned by the team that builds the models and therefore can configure it any way they want. For the marketplace, it doesn't change anything when we want to do an experiment. They send a request to the API gateway like always, but now we, by owning the API gateway, can decide how do we route this request to the different models that we have. And that way we can be autonomous, fully autonomous in running experiments while operating in the federated business context. We do tell the marketplaces that we're running experiments so that they understand what's happening to their users, but the autonomy part means we don't no longer depend on their backlog. So with that, those architecture pieces in place, we can start looking at building data products. And I want to go through 2 use cases. One is around personalization, and the other is around computer vision. So personalization is something where we want to personalize the user experience to basically their personal preferences, right? So in a marketplace, this typically means that the search of a user is supported by a number of relevant recommendations for the user. And to be able to build such a product, the first thing we need to do is calculate the similarity between items. You see here a few pictures of items on marketplaces. And in the green here, you see relevant recommendations, and in the red, not so relevant recommendations. So the bikes is one example, and the 2 cars, the 2 Audis is another example. And Here you see two cars that in a user study were deemed to be not so relevant because they are not very similar types of cars. Now, this is a very well understood problem. It's researched for many years, but the challenge that we face in an online marketplace is that our inventory is highly volatile. So what does that mean? In an e-commerce, you typically have maybe hundreds of items of stock, so you have a pretty stable inventory. But in a marketplace, every item is unique. So once you sell it, it's gone. Right? So that means many of our items get sold within hours, within days, right? And that means for this purpose that we deal typically with very few clicks to be able to calculate something like similarity on. So similarity is typically calculated using something called collaborative filtering, which basically means that it uses the clicks to determine the co-occurrence between ads, which users looked at which ads in the same user session. And after experimenting with many different models, we today have in production basically two approaches. One that relies on co-occurrence with the adjustments needed for the marketplaces, and one called add-to-vec, where we use a deep learning embedding approach to represent the similarity. And if you're curious, you can type add-to-vec in Google and you'll find a very nice blog post where this is described in more detail. So with those similarities calculated, we can now basically go to a personalized approach. We take the history of a user and we look at which ads, which items they have visited, and we look at what are similar items to those items, and we can create a homepage feed. You see here my homepage feed for Mark Plaat, so you get a bit of an idea what hobbies I'm into. And one thing that's very important when we calculate these personalized recommendations is the popularity of an item. Popular items get a lot of interactions and therefore will stand out in terms of being very related to all the other items. But from a marketplace point of view, if those popular items get already a lot of exposure and are therefore very likely to find a buyer soon. So they don't need much recommendation to get sold, right? So you want to take that into account to favor the liquidity of your marketplace. The liquidity of your marketplace basically means the probability that every user on your marketplace gets what he's looking for, whether it's a seller or a buyer. Another problem is the cold start problem. This basically means that when a new item is added to the marketplace, we don't have any clicks yet for that item. And that means that we need to look for other ways to calculate similarity. So we use something, we use the textual description of the ad to solve that. So we can calculate using some natural language processing capabilities, basically which ads look similar. In practice, that it turns out to be less accurate, but since we don't have the clicks yet, that is the only way you can go about. So we use multiple data sources to get the best in coverage, being able to recommend for all items, and accuracy. And then we take it further. We try to apply that personalization in other areas as well. So something we've worked on more recently is called complementary items. So a complementary item is basically an item that you typically buy in conjunction with another item. So this is a slightly more challenging problem because you can now not just look in the neighborhood of items, you need to have some knowledge about what typically is bought together. And also on complementary items, we have a very nice blog post on Medium if you're interested to learn more. Category-specific recommenders. We have generic algorithms that apply to all the items on our marketplaces. But for example, in the car vertical, there are certain attributes that are very key to making relevant recommendation. The mileage of a car is very determinant of its value. But also if a user is looking for a car with an automatic transmission, they're probably not interested in a car with a manual transmission. So taking these things into account make your recommendations more relevant, but means that you need a specific model for your use case. And finally, which picture to show on the listing. You have a feed, you have all the items in your feed, but what is the picture that is going to be most convincing to the user to say, yes, this is for me? And I put here a few examples of a house on our real estate marketplace in Spain. A house that's a bit out of my budget, but a very nice house. And which picture would you click on? That's basically the question, right? So we could use a model to learn this for each user individually and change which picture is shown with every listing. The point is that we use many different models to cover many different use cases and many different user profiles. And basically there is no one model to rule them all. Rather, we combine the models and apply the best combination to fit for the particular use case. So, as you get more confident in the performance of your recommenders, you can start applying it to different touch points. So, one example here is on our marketplace platforms. We allow users to send messages to each other. A buyer contacts a seller to say, hey, I'm interested in this item. Is this a good price for you? But it can happen that a seller doesn't respond. And then rather than having that be a kind of a dead-end street experience for the buyer, we could offer recommendations and say, well, there are these other ads that are very similar to the one that you just sent a seller a message to. Maybe you'll get more success there. Or in a newsletter. Initially, our newsletter was showing just the most recent ads that you visited. Well, you already visited those, so that's not very engaging. So we replaced that with recommendations. But the interesting thing there is that if you generate those recommendations at the time that you send the email, they might already be sold at the time that the user opens the email. Again, we have volatile inventory on marketplaces. So ideally, you generate this at open time for the user. So a few takeaways around personalization. Our vision is not to build the perfect model, but what I like to call a zoo of models, a collection of models that then you learn how to apply in the best way, or rather you use machine learning to learn when to apply which model at which point in time. And there are many touch points that you can apply this technology, but it's the same technology every time. So that's just broadening the impact that you can have with the technology that you already built. And finally, keeping recommendations fresh by leveraging multiple data sources is important to be successful here. Then let's go to the second data product that I want to talk about, based on computer vision. So computer vision has seen a tremendous increase in performance ever since the advent of deep neural networks. You've probably seen in the news things like deep fakes or being able to generate images from textual descriptions. But how can we actually use this in our business context? Well, one of the problems we have in our marketplaces is that adding an item to the marketplace takes some effort. You need to fill out quite a few fields to be able to get that item on the marketplace. You need to add the title, the category, the description of the item, the price, and pictures. So what we build is a solution that uses images to speed that up. So this is live today on Marktplaats if you want to try it. You make a picture of an item, and it's sent to our computer vision algorithm to then process that and decide what is the category that this item best fits in, and what is the typical price range that users would offer this item in, and other ads on our marketplace that are similar to this one. So that helps the users to speed up, and the way this works basically is we use a pre-trained neural net to calculate these embeddings. And you could go about two ways. You could use this as a classification problem, which means you have to now correlate the embedding of the image with the categories, or you could treat it as an image similarity problem, which means that you calculate the embedding of the image for all of the items in your marketplace, and then you say, okay, which item is this similar to? With those similar items, you can then just look at the metadata of those items and say, okay, this is the most common category among these, and this is the typical price range, and you have the data that you are looking for. These are very different, technically different approaches, but are they have implications on the performance of your model. And the ultimate vision I have here for this kind of application is that you're able to basically take your phone, walk through your house, and just make a video, and it just pops up all the prices of the items that are there, and you can say, oh yeah, maybe I'll sell this. So we're always looking for ways to push this further. So the takeaway here is that it's often not needed to build your own deep nets. You can use pre-trained ones. And consider using image similarity rather than classification in applying this in your business. And with that, I'm at the end of my talk. Thank you very much for listening, and have a great day.
All right, do we have a few questions? We have time for one or two. Well, I have a question. So looking at the difference between classification and image similarity, what type of performance differences do you see, and what are some of the key decisions that make you pick one or the other?
Yeah, so the complexity in treating this as a classification problem means that you need to really get this right, the decision boundary between the different categories going forward. And that is something that requires quite some tweaking, because all those different categories, they have many different attributes that play a role there. Well, in a image similarity case, we kind of abstract away from that, and we just look at the neighborhood of items and don't really worry too much about those decision boundaries. So that way, we are able to generalize that problem in a much better way.
Very good. Has using the image similarity, has that helped you identify some subcategories of items that you didn't have listed on the metadata before?
Like some attributes of items that,
or just a style of item that you really didn't have a clear-cut category for, that really requires its own different subcategory.
Yeah, absolutely. Like, as you work with this data, you start to see outliers, let's say, right? And our taxonomies are today something that's very manually curated by a team on the marketplace, right? So there is definitely space there for doing that in a more data-driven way, and maybe even a personalized way as well, right?
Okay. All right, thank you very much. Let's give him a big round of applause.
Thank you.